cybernetic systems from Japan. Established in 1985, cybernetic systems have been providing CAE solutions and IT solutions through the product sales, consulting, and software development for over 30 years now. Our partners up until this point are more than 20 vendor companies, including Ansys, Synopsys, and many others. Cybernetic systems provide all sorts of solutions that can fit most of the customer's needs. Those solutions you can see in this screen, including CAE solutions, AR/VR solutions, big data, IoT digital twin AI services, and IT solution and labs engineer services. We also acquired 3 developer companies, including Microsoft, Ansys, and Schematrix, to provide more comprehensive services and products to customers around the world. Our head office is in Tokyo, Japan. There are 4 sales subsidiaries in Asia, including China, Taiwan, Korea, and Malaysia. Cybernet Systems Malaysia is in Kuala Lumpur. Our business here mainly involves around CAE solutions, which is based on Ansys, and the IoT big data solutions, and also professional services. In CAE solutions, we provide Ansys mechanical, Ansys CFD, Ansys electronic solutions, and so on. And our technical resources, not only from local Malaysia, but also from Taiwan and Japan. That's all about our companies. Let's welcome Ren to introduce Ansys motor design and the analysis solution.
Hello everyone, I'm Wen from Cybernet, and today I will give you a presentation. Is a motor design process introduction. And this is my agenda. First, I will give you the introduction from Ansys motor design platform. And this is a motor design total solution from Ansys. And second, I will give you by using Ansys to do the motor design and analysis process. And finally, I will give you a simple conclusion. And for general motor design, and we have some process for my job. And last year and before I worked in E3, which is a research center for our government. And in E3, I will do I did many kinds of motor design, and this is my motor design process. First, I will give you define the design target, which is the power of voltage, current, efficiency. Also, we have some design targets from MVS and controller. And next, we should do the concept design for this motor. So we will to define which kind of motor we will design, like PM motor, IM motor, or SRM. And second, we will define the motor sizing, because if we are not design industry motor, such that we have some motor case to be commercialized, and so we have to define the motor size, in which if we use this motor in the car or in another application, then we have to do a motor length, wide, or size, and then for motor we should design a rated point, which is if my motor wants to design a 5 kilowatts performance, then we should do that. This 5 kilowatts is at which kind of torque and speed. And finally, in concept design, we should define the thermal performance. Although this kind of performance, some company or some designer will put this kind of performance in EM design process, or after design we should do some tests or experiments to find this. But in my design process, or using Ansys design process, we can define the thermal performance as a concept design process. And second, and next, we should do the EM design analysis. And if we define the motor sizing, motor type in concept design, and we can design the torque ripple, flux density, and slot magnetic size, and 3D analysis, transient performance, and voltage input, and to do the optimize process to for maximum efficiency or maximum torque, and so on. And after we finish the EM design, then we should do the mechanical and CFD analysis. And so we have to draw the cast for the motor, and so we should have the cooling design on the cast, and also we have to design which kind of the cooling method we should do, and such as a fan or water cool or oil cool. And so we also have to do is to check that rotor strength or cast strength, and also stator strength. And for mechanical analysis, we should define the natural frequency and also harmonic response. And we can do the NVH design to define the noise. And we can use CFD analysis to find the thermal and temperature rising, and so on. And after this analysis, we finish the motor design. But if you are not using an industry motor, it often use controller to control the motor, and so we should do the system analysis, because controller to control the motor, it should have the control strategy, and also we should do the system model for battery, controller, inverter, and also motor. So in Ansys, the role model can be used in system analysis. And Ansys has a corporate company named MDL, and there is and they have the model design software named ModelCAD, and this kind of software usually used for concept design. And in this in ModelCAD, we can use 4 modules. First is image. Image is such like 1D analysis solution for model design. And also we have thermal module, mechanical module, and lab module. And ModelCAD usually has a famous module is thermal module. And this type of module has a very accuracy solution for model thermal application. And so in ModelCAD, in model design, ModelCAD gives us a very rough but reliable reliable solution for water analysis. And for design and analysis process, Maxwell 2D and 3D, and can give us advanced magnetic modeling for such as top ripple and 3D, or we use a PM motor. We can see the skew effect, or also we can see the skin effect in motor. And so these two software can help us to do electric machine design, such as stator, rotor, winding, and also some kind of thermal formers. But Maxwell can only do the electromagnetic solution. But if we have to do the detailed mechanical and CFD designs, and we should use Ansys mechanical and Ansys CFD to do the LVH analysis and also cooling analysis. And finally, we should use system validation. We can use a Twin Builder or Explorer. We can build a kind of electric circuit model like PCM or other software. But the advantage of the Twin Builder and Explorer is we can use a role model inside the circuit model. A role model is the kind of model we can name reduce of model. It means that if we finish the Maxwell design, we can put this kind of FEM model to do the simply model as ROM inside the Twin Builder. So we can use a circuit like a control strategy and IGBT model in the Twin Builder, and to see the motor performance inside in the Twin Builder. And so we'll summarize the Ansys software. If we want to start from model design, we can use ModelCAD or iExpert in Maxwell. And after we finish the concept design, from by AutoCAD and or RX, we can transfer this model to Ansys Maxwell, do the FEA analysis. And next, we can use this model to transfer to the raw model in Simpler or Twin Builder to do a system design and analysis. And also, if we have some issue for mechanical or cooling, and we can use Ansys mechanical or CFD to do the structural analysis and thermal analysis. And Ansys have the advantage to do the co-simulation. And if you want to do EM to mechanical co-simulation, you can use Maxwell and mechanical to do that. And Maxwell can analyze the motor force, EM force, from magnet or winding, and then Maxwell can output the H force model or H force result into the mechanical, and so mechanical will have the force model or results from Maxwell, and then we can use this force to be the input and analyze the maybe strain or noise. And Ansys also have the solution for named VR experience, and this kind of software can let you to hear that the real motor noise from mechanical analysis results. So this is the NVH from Ansys solution. And if we want to do the thermal analysis for motor, and we have two methods. And one is in concept design, we can use AutoCAD and to do the thermal network kind analysis in only this software. So AutoCAD can give you the temperature rising or temperature development in the motor. And second, we can use Maxwell and thermal and like thermal software like Fluent CFD to do the co-simulation. And so we can use the EM loss results from Maxwell and mapping this kind of results into CFD. And so CFD can use the loss results from Maxwell, and it can compute the temperature or temperature rising from by CFD software. And we also can use this kind of co-simulation for bi-direction. It means that CFD computes finish the temperature computing, and it can put the temperature results into Maxwell. And so Maxwell can use this temperature result to choose the right material specification from FEM input. And so Maxwell can compute again EM loss. And because, as we know, the copper loss or the iron loss will be rising by temperature increasing. So if we have the different temperature status, we can compute the different EM loss. So if the temperature is right condition in Maxwell setting, and we can get the more accuracy EM loss results. And so we can do some iteration for bi-direction iteration, and we can get more accuracy results from this kind of approximation method. And this page will present some difference between Maxwell and AutoCAD. So Maxwell is the FEA tool, including pre-CAD model template-based solution, and named iExpert. And Maxwell have the different kind of excitation, such as voltage source, current source. But AutoCAD only have current source for analysis. But AutoCAD have very fast compute time because it uses 1D calculation and combined 2D FEA with in the AutoCAD analysis, and so it just with our time about 5 to 10 minutes, you can finish the model design. But Maxwell maybe we used to waste maybe 20 minutes to 1 hour to finish the 2D case. And also the Maxwell can analysis the efficiency map by toolkits and FEA solution. AutoCAD can do the efficiency map, just use the 1D analysis method to get the fast results. AutoCAD can consider drive cycle with temperature dependency. Maxwell should couple Ansys Fluent or CFD to do the coordination. And AutoCAD can do the duty cycle analysis with temperature envelope. And this kind of function I will introduce beside the next few pages. And so this is AutoCAD in the introduction. So AutoCAD have the 4 modules: image, thermal, mechanical, and lab. And AutoCAD is kind of the module-based design software. It means that we have some defined model types like brushless permanent magnet motor and induction motor, SR motor, and switch reluctance motor, and so on. So if we want to use if we want to design a linear motor or clopole motor, we can't use AutoCAD to do it because AutoCAD didn't give us this kind of model types. And so from first, we should do the model design by Emac, and so we can use the table kind of the input. So we can type the stator, outer diameter, inner diameter, and tooth width, and some kind of model design parameters into this table. And after we finish this table, we can compute the EN performance like torque, current, voltage, and so on. And also we can use Emac module to define the winding pattern and to check that the Fourier analysis of the voltage waveform. And and we also can analyze flux density plot in Emac because AutoCAD has stated to this FEA solver in Emac, and we can use FEA geometry by import the DXF file. So if there is no any so if we have specified AutoCAD CAD file, we can import this to analysis the motor performance. And in thermal module, it use the thermal network to analyze the model results. And so we can use thermal module to define the AutoCAD geometry and material. And also we can define the different cooling type in AutoCAD. So we can use AutoCAD to compute the temperature distribution and transient solution. And this page shows that AutoCAD thermal module within many cooling type, and also it has natural convection from housing and fan, and also we have the water jacket for water cooling, and also it has the oil cooling module inside. And AutoCAD is used thermal resistance network method to compute the temperature. It also can define the slot cross section for concentrated winding or hairpin winding. And there is very famous from AutoCAD is AutoCAD can consider the manufacturing data by AutoCAD MDL companies' experience. So for example, the stator and housing, there are some contact thermal resistance, and ModelCAD can let you to choose 3 or 4 kind of contact, like perfect contact, good contact, average contact, and poor contact. And these 4 contacts have different thermal resistance you can choose. And so if you know that your motor manufacturing performance and you can use this kind of thermal resistance for nearly to real case. And third, ModelCAD has the LED module, and it can do the efficiencies and loss maps, and you can do the peak torque speed curves and continuous torque speed curves and duty cycle analysis and open and short circuit tests and so on. And for this module, you can define the duty cycle like the plot is below, and this kind of module we usually use this to analyze EV traction motor, because this kind of motor we can use we test for UDDS pattern or NE95 pattern. And so if we want to analyze the energy consumption or this motor at this driving pattern, and we can use that module to analyze it. And AutoCAD and also can generate map and drive cycle data, and so we can do some optimization by building a response service of loss and current. And ModelCAD also can help us to define the peak torque peak TN curves and rated TN curves. And peak TN curves it considers the maximum voltage and current performance. And continuous TN curves it also consider the limit temperature, such like winding or rotor magnet. And the LED module also can compute some duty cycle, and if we use this duty cycle, we can check that the motor temperature rising and after 2 cycle or 5 cycle. So the plot below we can see that this is the 5 driving cycle temperature rising plot. So we can see that the temperature will be rising and then lower and higher and lower, and at any cycle after any cycle. And last is a ModelCAD mechanical module, and this module is very simple because it just to compute the rotor structure strength, and so but for PM motor, the rotor bridge strength is very important for a motor designer. So we can do this kind of analysis by yourself. And this is introduction for AutoCAD software. And next, I will give you some introduction for Maxwell 2D and 3D. And before that, I will give you some tips for AutoCAD. If we finish the AutoCAD design, and we can transfer to transfer AutoCAD model to Maxwell, and it uses script method, and so we can output AutoCAD to a script file, and in Maxwell we can just open this script file and we can build a same model of the this motor. And AutoCAD geometry also can export the 3D CAD model, and so we can use this model to this 3D CAD model into mechanical or CFD. And so next, I will give you some tips for Maxwell 2D and 3D design. And if you just only have Maxwell, you don't have AutoCAD, you can start model design from iExpert. And this is a kind of simple tool help you to building model. And so there have many kinds of model. It not only have IMPN, SRM motor, but also have some linear motor and couple motor and so on. So ISO has many kind of module inside this software. And if we use BODC, for example, we can get the 4 motor performance curve in by iExpert, like TN curve, PN curve, iron curve, and the efficiency curve. And if we should do if we have to do the complex model design such like PNSM, and we also can use iExpert to do some performance analysis, and we can get the power, efficiency, torque, and loss. And if we want to see more detailed analysis, we can transfer the iExpert model to Maxwell model. So after we transfer to a Maxwell model, first we should do the back EMF analysis. If our motor is PSM motor, we should do is back EMF analysis. And in Maxwell, we can see the back EMF curve, and also we can do the FFT analysis to see the harmonic performance. And also we can analyze flux density and flux line distribution. And after we do the back-EMF analysis, we call no load analysis. And next, we should do the NTPA analysis for PSM. And NTPA, we can use Maxwell current source to do this. And so we can use this kind of function to get our maximum torque ampere performance to find the good torque performance and torque angle. And also we should see the flux density plot at this step. And we also can use Maxwell to do the magnetization analysis. And so if as you know, the motor design such as EM motor, we are all afraid the demagnetization phenomenon for this kind of motor. So we should do this kind of analysis to check that the motor, the magnetic thickness is enough or too thin. And also, if we use 2D analysis, we can use the equivalent skill model in Maxwell, and we have two kind of skill type we can choose, and we can use 2D Maxwell 2D analysis to do the skill motor skill performance. And Maxwell has the optimization module, so we can type the variable we can type the variable into such as slot opening, magnet thickness, or magnet length, and we can choose some variable to do the optimization. So in this case, it uses magnet opening angle and magnet length to do the low cooking torque optimization. So after optimization, we can get a very small cooking torque design for this motor. And Ansys Maxwell have the very smart toolkit for performance map. So we can just use this kind of toolkit to do the efficiency map, loss map, and so on. And now Maxwell give this toolkit to analyze PM, IM, and synchronous reductions motor. These three kind of machine type, and it can compute the current source with AC loss and friction loss, and it can also do the multi-phase efficiency map analysis, such as 3-phase, 5-phase, and 6-phase. And so this is a map analysis by toolkit. So you can see that current map, voltage map, loss map, and also gamma map. Gamma map is the torque angle map. So you can see that from low speed, torque angle is very low, and after we increase the speed after corner speed, we can get very high torque angle for brush weakening. And also we should do the EM force analysis, and so we can see the EM force mapping, and also we can check that the force will be balanced or not. So we can use this kind of information to check that this motor are a good design. This kind of motor doesn't have NVH issue. And we also can use the different different rotor position to do the eccentric health and unbalanced EM force to check the EM force distribution. And we can use AutoCAD geometry go to workbench. This will be present for. And after we finish the measure analysis, we can give the loss model to Ansys CFD, and CFD will compute the temperature distribution and give the temperature measurement into Maxwell. And so Maxwell will choose the different temperature magnet performance into the original model, and to do again loss analysis. So this is the bi-direction co-simulation between Maxwell and CFD. And for NVH simulation, we have the workflow from Maxwell to mechanical. Mechanical has two modules. One is mechanical, and the second is acoustic module. So we can compute the EM force from Maxwell, and next we can use workbench to send these results to mechanical, and mechanical will compute the structure strength and also velocity, and this velocity information can input to acoustic module to analyze the noise. So you can see that the motor SPL will show in this plot. Because in this presentation we also we only introduce only AutoCAD and Maxwell. So we just introduce the model design process from design targets to EM design and analysis. And after that, you can use more analysis from mechanical and CFD, such as structure or nature frequency, and also you can use CFD to do the any kind of cooling, or you have to install the fan into the motor. And so you can use CFD to show how to see the fan and air, how to flow inside the motor. And finally, you can also use control and to do the system analysis. And so that is the presentation today I shared. Thank you.